Picture the void between the stars, a darkness so complete that light itself seems to surrender to the endless expanse. Here, in the spaces where no sun has ever shone, where temperatures hover just above absolute zero, something moves through the cosmic night. It has been traveling for millennia, perhaps millions of years. A silent wanderer carrying secrets from a stellar system so distant that its light has never touched our eyes. This is 3I Atlas, a name that barely captures the profound mystery of its existence. As it drifts through the interstellar medium, this cosmic visitor begins to catch the first whispers of our sun's influence. Solar particles racing outward at incredible speeds start to interact with its ancient surface. Something stirs within its frozen heart. From Earth, our most sensitive instruments detect it as little more than a mathematical anomaly, a point of light moving against the star field in a way that defies the gravitational choreography of our solar system. The astronomers who first spotted it through the Atlas telescope network knew immediately they were witnessing something extraordinary. Unlike the countless comets that call our solar system home, this object follows a hyperbolic trajectory. It will not return. It will not be captured by our sun's embrace. It is a true outsider, bound for destinations we cannot imagine, carrying with it the chemical fingerprints of alien worlds. But as it draws closer to our star, something unexpected begins to happen. The object starts to glow. A faint, ethereal light begins to emanate from its core, creating a halo of gas and dust that astronomers call a coma. Yet there is something unsettling about this awakening, something that doesn't quite match the models and equations that have guided our understanding of such phenomena for generations. Scientists speak of it in measured, clinical terms. They describe its velocity, its trajectory, its estimated composition, but in the quiet moments between observations, when the data streams are processed and the instruments fall silent, there is something else in their voices, a note of uncertainty, perhaps even a whisper of fear. For 3 Atlas represents more than just another celestial object to catalog and study. It is a messenger from the deep cosmos, carrying information about stellar systems that formed when our own was still a swirling disk of dust and possibility. It forces us to confront a humbling truth. We are not alone in the universe, and the universe is far stranger than we dare to imagine. As this interstellar wanderer continues its journey toward our sun, growing brighter and more active with each passing day, humanity watches and wonders. What secrets does it carry in its ancient ice? What stories are written in the complex chemistry of its tail? And perhaps most unsettling of all, why does its behavior seem to challenge everything we thought we knew about such cosmic visitors? Meanwhile, in the cold reaches of space between Mars and the asteroid belt, 2 robotic sentinels maintain their eternal watch. Mars Express and the ExoMars Trace Gas Orbiter, designed to study the red planet's atmosphere and surface, suddenly find themselves witnesses to something far more extraordinary than their original mission parameters ever anticipated. The date is October 3rd, and 3I Atlas passes within 18.6 million miles of Mars, a cosmic near miss that places it perfectly within the observational range of the orbiting spacecraft. The instruments aboard these mechanical explorers, calibrated to peer down at Martian terrain from mere hundreds of miles above, now strain to capture images across the vast emptiness of interplanetary space. What they record is both haunting and perplexing. In the grainy, enhanced images transmitted back to Earth, 3I Atlas appears as a fuzzy white dot, a pale specter moving against the star field. But it is what surrounds this central point that captures the attention of scientists across the globe. The coma, that ghostly halo of gas and dust, appears larger than expected for an object at such distance. Frame by frame, as the spacecraft's cameras track the visitor's movement, something remarkable becomes apparent. The object seems to be growing, not just in apparent size as it approaches our sun, but in actual luminosity and extent. Dr. Elena Vasquez, analyzing the data at the European Space Agency's Operations Center, notices something that makes her pause. The brightness variations in the coma don't follow the smooth patterns typically associated with cometary outgassing. Instead, there are subtle pulsations, rhythmic changes in intensity that occur at regular intervals. It's almost as if it's breathing, She confides to a colleague during a late-night analysis session. The comet, meant as casual observation, will later take on a more ominous significance as additional data arrives. The ExoMars Trace Gas Orbiter, equipped with sophisticated spectrographic equipment, begins to detect unusual chemical signatures in the expanding coma. The typical water vapor and carbon dioxide expected from sublimating ice are present, but there are other compounds, complex organic molecules that shouldn't exist in such quantities so far from the warming influence of our sun. Colin Wilson, project manager for both Mars missions, watches the data streams with growing fascination and unease. These spacecraft, designed to unravel the mysteries of Mars' potentially habitable past, have inadvertently become humanity's first detailed observers of an interstellar visitor in its active phase. The images, though captured by instruments struggling to focus across millions of miles, reveal something that will haunt the scientific community for months to come. The tail of 3I Atlas, that stream of particles blown away by solar wind, doesn't behave as theory predicts. Instead of forming a smooth, consistent plume pointing away from the sun, it shows irregularities, kinks and bends that suggest something is influencing its formation from within. As the spacecraft continue their observations over the following days, the anomalies only multiply. The central nucleus, that solid core of ice and rock, appears to be rotating, but the period doesn't match what would be expected from a naturally formed body. The rotation seems too regular, too precise, as if governed by some internal mechanism rather than the chaotic tumbling typical of comets. By October 7th, as 3I Atlas moves beyond the optimal viewing angle of the Mars orbiters, the scientists have collected enough data to fill volumes of analysis papers, but they also have enough questions to fuel decades of speculation. The fuzzy white dot in their images has become something far more complex and unsettling than anyone anticipated. As autumn deepens on Earth, astronomers around the world pore over trajectory calculations that seem to defy conventional understanding. 3I Atlas races through space at 137,000 miles per hour, a velocity that speaks of origins in stellar systems far beyond our cosmic neighborhood. To comprehend such speed, consider that the fastest human-made object, the Parker Solar Probe, reaches a maximum velocity of 430,000 miles per hour only when diving directly toward the sun. Yet 3I Atlas maintains its tremendous pace while following a hyperbolic orbit, the mathematical signature of an object that will never return. Dr. Maria Santos, a celestial mechanics expert at the Jet Propulsion Laboratory, runs the calculations again and again. Each time, the numbers tell the same impossible story. For an object to achieve and maintain such velocity naturally, it would need to have been ejected from its parent star system with tremendous force, perhaps during a stellar collision or the violent death throes of a massive star. But there is something else hidden in the orbital data that troubles her. The object's acceleration doesn't follow the smooth curve expected from gravitational interactions alone. As 3I Atlas approaches our sun, it speeds up more than physics predicts. The additional acceleration is subtle, but measurable, and completely unexplained. This phenomenon, known as non-gravitational acceleration, has been observed in other comets before. Usually it's attributed to the rocket effect of sublimating ice-creating jets of gas that push against the comet's surface. But 3I Atlas exhibits this behavior while still too far from the sun for significant sublimation to occur. The implications are unsettling. Either this interstellar visitor contains some form of exotic ice that sublimates at lower temperatures than anything in our solar system, or something else entirely is responsible for its anomalous acceleration. Some researchers quietly speculate about electromagnetic effects, magnetic fields, or even more exotic possibilities that challenge our fundamental understanding of physics. As October progresses, amateur astronomers with powerful telescopes begin to track the object's journey. Their observations, shared through online forums and astronomical societies, add to the growing database of anomalous behavior. The comet's brightness continues to increase, but not in the steady, predictable manner typical of approaching comets. Instead, 3I Atlas exhibits sudden brightening events, short periods where its luminosity increases dramatically before returning to expected levels. These outbursts occur without apparent pattern, adding another layer of mystery to an already enigmatic visitor. Professor James Mitchell, analyzing photometric data from ground-based observatories, notes that the brightness variations seem to correlate with the object's rotation period. But the relationship is complex, suggesting that whatever is causing the outbursts is not uniformly distributed across the object's surface. It's as if there are specific regions or features that activate as they rotate into sunlight, Mitchell explains to his graduate students. But we have no precedent for such behavior in natural comets. The speed of 3I Atlas becomes more than just a measurement. It becomes a symbol of how much remains unknown about the cosmos beyond our solar system. This visitor from the dark carries with it the physics of alien stellar environments, the chemistry of distant worlds, and perhaps most unsettling of all, behavior patterns that suggest levels of complexity we are only beginning to comprehend. As the object continues its relentless journey toward the sun, its tremendous velocity serves as a constant reminder that we are witnessing something truly extraordinary, a cosmic phenomenon that challenges our most basic assumptions about the nature of interstellar space and the objects that call it home. In the sterile environment of the European Space Agency's Mission Control Center, Dr. Elena Vasquez stares at her computer screen with a mixture of excitement and unease. The raw data from the ExoMars Trace Gas Orbiter has just arrived, transmitted across millions of miles of space in strings of ones and zeros that will soon reveal humanity's first detailed glimpse of an active interstellar visitor. The initial images are disappointing to untrained eyes. Grainy, low-contrast frames showing star fields punctuated by cosmic ray hits and instrumental noise. But buried within this digital static lies something extraordinary. A faint white smudge moves across the frames, barely distinguishable from background artifacts. Enhancement Algorithms, Level 3, Vasquez commands the imaging software. Slowly, the computer begins to reveal what the human eye cannot see. The smudge sharpens, brightens, takes on definition. What emerges is simultaneously beautiful and deeply unsettling. The central nucleus of 3I Atlas appears as a brilliant point of light, so overexposed in the spacecraft's instruments that it bleeds into the surrounding pixels. But it is what surrounds this blazing core that captures the attention of everyone in the room. A gossamer halo of gas and dust extends outward in an almost perfect sphere, growing fainter toward its edges until it fades into the cosmic background. "That's not right," whispers Dr. James Foster, a veteran comet researcher who has studied hundreds of such objects over his career. "Comets don't form symmetric comas like that. Solar wind should be shaping it, distorting it. This looks almost, controlled." As the enhancement process continues, more details emerge from the digital noise. The coma is not uniform. It contains structures, filaments of brighter material that spiral outward from the central nucleus, like the arms of a cosmic galaxy. These features rotate as the object spins, creating a hypnotic pattern that seems to pulse with its own internal rhythm. The tail, that stream of particles blown away by solar pressure, presents its own mysteries. Rather than forming a single, smooth plume pointing away from the sun, it appears to bifurcate, splitting into multiple streams that weave through space like cosmic serpents. The brightness of these streams varies independently, creating a complex light show against the star field. Dr. Vasquez zooms in on individual frames, searching for clues to explain the anomalous structures. In the highest resolution images, she begins to notice something that makes her pause. The surface brightness of the coma shows periodic variations, not random fluctuations, but regular patterns that repeat with mechanical precision. "Look at this," she calls to her colleagues, pointing to a series of measurements on her screen. The brightness oscillations have a period of exactly 734 hours. No variation, no drift. That's impossibly precise for a natural rotation. The implications sink in slowly. Natural objects in space, asteroids, comets, even planets, exhibit rotation periods that vary slightly due to gravitational influences, internal stress, and countless other factors. But 3I Atlas maintains its rhythm with atomic clock precision, as if governed by some internal mechanism rather than the chaotic forces of celestial mechanics. As additional frames are processed, the team begins to map the object's rotation in detail. The nucleus, barely resolved even in the enhanced images, appears to be elongated, perhaps similar to Oumuamua's unusual proportions. But unlike its predecessor, 3I Atlas maintains a stable orientation as it rotates, its long axis pointing consistently in a specific direction. "It's like a compass needle," observes Dr. Foster, studying the alignment data. But what could it be pointing toward? The question hangs in the air as the team continues their analysis. Each new image reveals additional mysteries, additional behaviors that challenge their understanding of how interstellar objects should behave. The symmetry of the coma, the precision of the rotation, the complex structure of the tail, all suggest levels of organization that seem impossible for a natural body. As news of the enhanced images spreads through the scientific community, researchers around the world begin their own analyses. Spectroscopic data reveals unusual chemical signatures, complex organic molecules that shouldn't exist in such quantities so far from warming stellar radiation. Magnetic field measurements detect organized patterns that suggest internal structure far more complex than simple rock and ice. The first images of 3I Atlas in its active state mark a turning point in humanity's understanding of interstellar visitors. No longer can these objects be dismissed as simple cosmic debris. They represent something far more complex, far more organized, and far more unsettling than anyone dared imagine. Deep within the heart of 3I Atlas lies a frozen library of cosmic history. This nucleus, perhaps no more than 3 miles across, contains ice that formed in the outer reaches of an alien star system billions of years ago. It is a time capsule from the early universe, carrying within its crystalline structure the chemical fingerprints of stellar processes that predate our own sun by eons. To understand the significance of this interstellar ice, we must consider the profound journey it has undertaken. When our solar system was still a nascent disk of dust and gas, slowly condensing under the influence of gravitational collapse, 3I Atlas was already ancient. It had been wandering through the galaxy's spiral arms, moving through regions of space where different stellar populations were born, lived, and died. The ice within this cosmic visitor contains isotopic ratios that speak of its alien origins. The balance of oxygen-16 to oxygen-18, the proportion of deuterium to hydrogen, the presence of trace elements like nitrogen-15, all tell a story of formation in environments radically different from our own stellar neighborhood. These signatures are like fingerprints, unique identifiers that reveal the type of star system where the object originated. Dr. Rebecca Martinez, a planetary scientist specializing in cometary composition, studies the spectroscopic data transmitted from various space-based telescopes with growing fascination. "This isn't just frozen water and carbon dioxide," she explains to her research team. "We're seeing complex organic compounds, amino acid precursors, aromatic hydrocarbons, even what might be primitive protein structures. The implications are staggering. If 3I Atlas carries organic compounds of such complexity, it suggests that the chemistry of life might be far more widespread in the galaxy than previously imagined. These molecules, preserved in the deep freeze of interstellar space, could represent the building blocks of biology from stellar systems that died before Earth's continents took their current form. But there is something else in the spectroscopic data that puzzles researchers. The ice appears to be arranged in layers like the rings of an ancient tree. Each layer tells the story of a different phase of the object's journey, periods when it passed through dense molecular clouds, encountered stellar winds from dying stars, or absorbed cosmic rays during its lonely traverse through the void. The outer layers show signs of recent processing, chemical changes that have occurred as 3I Atlas approaches our Sun. But the inner layers remain pristine, unaltered since their formation. These deepest regions contain isotopes that don't match anything found naturally in our solar system, elements that speak of nuclear processes occurring in stars with masses and compositions unlike our own Sun. As the object continues to approach our star, the warming process accelerates. The outermost layers of ice begin to sublimate, turning directly from solid to gas and carrying with them clouds of ancient dust. This outgassing creates the coma and tail that make the object visible to our instruments, but it also represents the gradual destruction of an irreplaceable scientific treasure. Each particle of gas and dust blown away by solar wind carries with it information about conditions in the early galaxy. Complex molecules that took millions of years to form in the frigid depths of space are dissociated by ultraviolet radiation in mere seconds. The cosmic library is being erased even as we struggle to read it. Dr. Martinez and her colleagues work frantically to extract as much information as possible before it's too late. They analyze the chemical composition of the expanding coma, looking for clues about the internal structure of the nucleus. What they find suggests layers of different ice compositions, some rich in water, others dominated by carbon dioxide or more exotic frozen gases like methane and ammonia. But beneath these familiar compounds lie signatures of something unprecedented. The deepest layers appear to contain isotopes of elements that are extremely rare in our solar system, products of stellar nucleosynthesis that occurred in massive stars that died in supernova explosions before our Sun was born. It's like finding a message from the early universe, Martinez confides to a colleague during a late-night analysis session. This object has witnessed the galaxy's evolution in ways we can barely imagine. It's traveled through stellar graveyards, absorbed the ashes of dead civilizations, and now it's bringing all of that history to us. The icy core of 3I Atlas represents more than just frozen water and simple compounds. It is a cosmic artifact that connects our solar system to the broader tapestry of galactic evolution, carrying within its ancient ice the seeds of life and the memories of worlds that existed when the universe was young. Throughout human history, our ancestors have gazed upward at the night sky and found patterns, stories, and meaning in the celestial dance above. Among the most powerful and persistent of these cosmic narratives are the myths of wandering stars, celestial visitors that appear without warning, blaze across the heavens and disappear into the unknown, leaving behind only memories and legends. In ancient Babylon, astronomers who meticulously tracked the movements of planets and stars recorded occasional visitors that followed no predictable path. They called these objects wild hair stars and believed they carried messages from the gods, omens of great change, harbingers of transformation that could alter the fate of kingdoms and civilizations. The Maya, with their sophisticated understanding of astronomical cycles, spoke of star demons that arrived from the void beyond the familiar constellations. Their codices described these visitors as beings of light and ice that brought with them the breath of distant worlds. The appearance of such objects was said to mark the transition between cosmic ages, moments when the very fabric of reality shifted and new possibilities emerged. Celtic druids told stories of the Wanderer's Light, a ghostly flame that appeared in the sky during times of great upheaval. According to their oral traditions, this light carried the spirits of warriors who had died in battles so distant that their echoes still traveled through the void. When the Wanderer's Light appeared, it meant that the barriers between worlds had grown thin, allowing influences from beyond to touch the realm of the living. In ancient China, court astronomers maintained detailed records of guest stars and broom stars, celestial phenomena that appeared suddenly and disrupted the eternal order of the heavens. These were often interpreted as reflections of political turmoil or divine displeasure. But some texts hint at a deeper understanding. A few scholars suggested that these visitors came from the realm of the outer darkness, carrying with them the essence of worlds that existed before the current cosmic cycle began. Norse mythology speaks of star wolves that hunt across the sky, pursuing the sun and moon through their eternal journeys. But some versions of these tales describe wolves that come from beyond the known cosmos, predators of light that carry within their bellies the frozen hearts of dead stars. When such creatures appear, they herald the approach of Ragnarok, the twilight of the gods and the end of the current world order. Dr. Amanda Reeves, an anthropologist who studies the intersection of astronomy and mythology, has spent years collecting these ancient stories. What strikes me, she observes, is the remarkable consistency across cultures that had no contact with each other. They all describe celestial visitors as transformative forces, agents of change that bring influences from beyond the familiar world. The descriptions in these myths often contain surprisingly accurate details about cometary behavior. Ancient texts speak of visitors that grow brighter as they approach the sun, develop flowing tails that point away from the solar disk, and exhibit unpredictable changes in brightness and appearance. These observations, made thousands of years before the development of modern astronomy, suggest that our ancestors were careful observers of phenomena they couldn't scientifically explain. But there are elements in these mythological accounts that don't match typical cometary behavior. Some stories describe visitors that pulse with their own internal light, exhibit geometric patterns in their tails, or maintain precise timing in their appearances. These details, dismissed by earlier scholars as poetic embellishment, take on new significance in light of the anomalous behavior exhibited by recent interstellar visitors. The Aboriginal Australians of the Central Desert region speak of ancestor lights that return from the dreamtime to check on the progress of the world. These lights are said to carry the memories of the first beings who shaped the landscape and established the laws that govern natural phenomena. When an ancestor light appears, it brings with it the possibility of new knowledge, but also the risk of profound disruption to the established order. Hindu astronomical texts describe Ketu, shadow planets that periodically manifest in the visible sky as harbingers of cosmic change. These entities are said to exist normally in invisible realms but occasionally cross into our dimensional space, bringing with them influences that can alter the course of history. The appearance of Ketu is associated with periods of revelation, moments when hidden truths about the nature of reality become accessible to human consciousness. As 3I Atlas continues its journey through our solar system, these ancient myths take on renewed relevance. Perhaps our ancestors, lacking our modern scientific instruments, developed different ways of perceiving and interpreting cosmic phenomena. Their stories might encode observations and insights that our current methodological frameworks are not equipped to recognize or understand. The myth of the wandering star serves as a reminder that humanity has always known, at some deep level, that we are not alone in the universe. Our cosmic visitors carry with them not just ancient ice and alien chemistry, but the weight of human imagination and the persistent hope that somewhere in the vast darkness, there are answers to questions we are only beginning to learn how to ask. As October deepens and 3I Atlas continues its approach toward the sun, the data flowing from Earth's most sophisticated instruments begins to reveal patterns that challenge every model of cometary behavior. In laboratories and observatories around the world, scientists stare at their computer screens with growing unease, struggling to reconcile what they're seeing with everything they thought they knew about interstellar objects. Dr. Elena Vasquez has barely slept in 3 days. The enhanced images from the Mars orbiters continue to arrive, each frame adding new layers to an increasingly complex puzzle. She focuses her attention on the brightness variations in the coma, using specialized software to map the intensity changes across different wavelengths of light. What she discovers makes her question her own instruments. The brightness fluctuations don't follow the chaotic patterns expected from random outgassing events. Instead, they pulse with mathematical precision, regular intervals that can be measured to the microsecond. The primary cycle repeats every 7.34 hours, but buried within this rhythm are secondary patterns, harmonics that suggest multiple processes operating in perfect synchronization. "Look at this frequency analysis," she calls to Dr. James Foster, pointing to a waterfall display of spectral data. The variations show harmonic relationships, exact integer multiples of the base frequency. That's not how nature works. Foster studies the display with growing concern. In his decades of comet research, he has never encountered such organized behavior. Natural objects tumble chaotically through space, their rotation periods gradually changing due to outgassing forces and gravitational influences. But 3I Atlas maintains its rhythm with the precision of a cosmic metronome. Meanwhile, at the Arecibo Observatory in Puerto Rico, Dr. Carlos Mendez aims the massive radio telescope at the approaching visitor. He expects to detect the characteristic emissions from sublimating water vapor and other common cometary gases. Instead, his instruments record something unprecedented: coherent radio signals with narrow spectral lines that pulse in perfect synchronization with the optical brightness variations. "This is impossible," Mendez mutters to his research assistant. "Comets don't emit coherent radio waves. They don't have the internal structure necessary to generate such signals." The radio emissions show complex modulation patterns, information encoded in the signal structure that resembles data transmission protocols. When Mendez runs the signals through pattern recognition software originally designed to search for extraterrestrial intelligence, the computer identifies statistical anomalies that suggest non-random content. At NASA's Deep Space Network in California, massive antennas designed to communicate with interplanetary spacecraft begin detecting sporadic signals from 3I Atlas. These transmissions are weak, barely above the noise floor, but they occur at precisely timed intervals that correlate with the object's rotation period. Dr. Sarah Kim, analyzing the Deep Space Network data, notices something that makes her hands tremble as she types her preliminary report. The signal strength varies in a pattern that matches no known astronomical phenomenon. During certain portions of the object's rotation cycle, the emissions increase dramatically, as if specific features on the surface are coming into alignment with Earth. The magnetic field measurements from space-based instruments reveal equally disturbing anomalies. Unlike typical comets, which have virtually no magnetic signature, 3I Atlas generates a complex magnetic environment that extends far beyond its visible coma. The field lines form geometric patterns, spirals and helices that maintain their structure, despite the turbulent environment of the expanding gas cloud. Dr. Lisa Chen, a plasma physicist studying the magnetic data, runs simulation after simulation, trying to understand how such organized fields could form naturally. Every model fails to reproduce the observed patterns. "It's as if there's something inside the nucleus generating and controlling these magnetic fields," she confides to her research team during a late-night analysis session. The spectroscopic data presents its own mysteries. While the expected water vapor and carbon dioxide are present in the expanding coma, there are also spectral lines that don't match any known molecular species. Some of these unknown compounds appear to be organized in crystalline structures that maintain their organization even in the chaotic environment of the coma. "We're seeing molecular assemblies that should dissociate instantly in the vacuum of space," explains Dr. Martinez, studying the chemical data. "But somehow they're remaining stable, even growing more complex as they move away from the nucleus." The thermal imaging reveals temperature distributions that defy conventional physics. While the sunward side of the object shows the expected warming from solar radiation, there are hotspots scattered across the surface that appear to be generating their own heat. These thermal anomalies pulse in rhythm with the optical and radio variations, suggesting they're all manifestations of the same underlying process. As the anomalous data accumulates, a small group of researchers begins to quietly discuss possibilities that would have been dismissed as science fiction just months earlier. The precision of the timing, the coherence of the signals, the organized nature of the magnetic fields, all point toward levels of complexity that seem impossible for a natural object. But what alternative explanations could account for such behavior? The implications of each possibility are more unsettling than the last, forcing humanity to confront questions about the nature of our cosmic visitors that challenge our most fundamental assumptions about the universe and our place within it. In the realm of modern astronomy, the act of observation has evolved far beyond simply looking through telescopes at points of light in the sky. Today's cosmic detectives employ a sophisticated arsenal of instruments that can perceive wavelengths of radiation invisible to human eyes, analyze the chemical composition of objects millions of miles away, and extract information from the faintest whispers of electromagnetic energy crossing the void. The Hubble Space Telescope, humanity's most famous eye in the sky, turns its ancient gaze toward 3I Atlas in late July. From its orbital perch above Earth's distorting atmosphere, Hubble captures images in visible light that reveal details invisible to ground-based observers. The resulting photographs show a ghostly visitor wrapped in veils of expanding gas and dust, its central nucleus blazing like a cosmic beacon against the star field. But Hubble's most important contribution comes not from what it sees but from what it measures. Using precise photometric techniques, the telescope's instruments determine that the nucleus of 3I Atlas measures between 1,000 feet and 3.5 miles across, a surprisingly narrow range that suggests the object has a more regular shape than typical comets. The size constraints are telling us something important, observes Dr. Jennifer Walsh, a Hubble imaging specialist. Most comets are irregular chunks of debris, but our measurements suggest 3I Atlas has geometric proportions that don't match random fragmentation patterns. Meanwhile, the James Webb Space Telescope, with its massive mirror and advanced infrared capabilities, peers deeper into the invisible spectrum. In near-infrared light, 3I Atlas reveals an entirely different character. The hot dust in its coma glows with complex patterns that show spiral structures extending far beyond the visible envelope. Webb's spectroscopic instruments detect absorption lines that speak of exotic chemistry, molecular combinations that form only under extreme conditions of temperature and pressure. Some of these compounds are so rare that they exist for mere microseconds in terrestrial laboratories, yet they appear to be stable and abundant in the environment surrounding 3I Atlas. The newest addition to our observational fleet, the SphereX telescope, conducts a detailed survey of the object from August 7th through 15th. This specialized instrument creates three-dimensional maps of the chemical composition throughout the expanding coma, revealing how different compounds are distributed in space and time. What SphereX discovers challenges fundamental assumptions about cometary physics. Instead of the random mixing expected from chaotic outgassing, the chemical species are organized in discrete layers and filaments. Complex organic molecules form chains and networks that extend across thousands of miles, maintaining their structure despite the violence of solar radiation and particle bombardment. Dr. Michael Torres, analyzing the SphereX data, struggles to understand how such organization could persist in the harsh environment of interplanetary space. We're seeing molecular architectures that would be impressive in a biology laboratory, he explains to his colleagues. But this is happening in vacuum conditions that should destroy any complex chemistry within seconds. Ground-based telescopes add their own unique perspectives to the growing database of observations. The Gemini South Telescope in Chile, equipped with advanced adaptive optic systems, captures images of the object's tail that reveal structure invisible to space-based instruments. The tail, that stream of particles blown away by solar wind, shows a complexity that defies conventional models. Instead of a simple plume pointing away from the sun, multiple streams weave through space in patterns that seem almost choreographed. Some streams are rich in dust particles, others dominated by ionized gases, and still others contain molecular species that shouldn't exist so far from the nucleus. It's like watching a cosmic dance, observes Dr. Patricia Gomez, studying the tail dynamics. Each component moves according to its own rules, but somehow they all coordinate to create these beautiful, impossible patterns. Radio telescopes around the world contribute their own insights to the puzzle. The Very Large Array in New Mexico maps the magnetic field structure around 3I Atlas, revealing organized patterns that extend far beyond the visible coma. These fields appear to be guiding the movement of charged particles, creating the complex tail structures observed in optical wavelengths. But it is perhaps the negative results that prove most unsettling. Despite extensive searches with humanity's most sensitive instruments, 3I Atlas exhibits none of the random variations, structural irregularities, or chaotic behaviors that characterize natural comets. Every measurement reveals order where chaos should reign, precision where randomness should dominate. The collective observations from this diverse array of instruments paint a picture of an object that seems to exist at the boundary between the natural and the engineered. Each new wavelength of observation adds detail to a portrait that becomes more complex and more troubling with every passing day. As the data accumulates in computer databases around the world, a small but growing group of researchers begins to wrestle with implications that extend far beyond conventional astronomy. The art of seeing the invisible has revealed something that challenges not just our understanding of comets, but our assumptions about what is possible in the universe. In the pre-dawn hours of October 15th, Dr. Rebecca Martinez sits alone in her laboratory at the Instituto de Astrofísica de Canarias, staring at a computer screen that displays what might be the most significant discovery of her career. The photometric data from multiple telescopes, carefully synchronized and cross-calibrated, reveals a pattern hidden within the brightness variations of 3I Atlas that defies every natural explanation she can imagine. The object pulses, not with the irregular flickers expected from random outgassing events or chaotic rotation, but with the precision of a cosmic lighthouse. Every 734 hours, the brightness peaks in a specific sequence, 3 rapid flashes followed by a longer, more intense burst, then a gradual fade to minimum intensity before the cycle begins again. "It's like a heartbeat," she whispers to the empty room, her voice barely audible above the hum of computer cooling fans. The metaphor is apt in more ways than she realizes. The timing is so precise that it could serve as an interstellar chronometer, maintaining accuracy that rivals atomic clocks. Martinez has spent 3 days eliminating potential explanations. Rotation alone cannot account for the complex brightness pattern. It would require surface features with impossible geometric precision. Outgassing events occur randomly as different regions of ice sublimate under solar heating. They don't follow mathematical sequences. Even if the object contained some form of exotic ice that sublimated in rhythmic pulses, the timing would drift as internal pressures changed. But the brightness variations show no drift, no degradation in their precision. If anything, the pattern has become more pronounced as 3I Atlas approaches the Sun, suggesting that whatever mechanism generates the pulses grows stronger under solar heating rather than weaker. The spectroscopic data adds another layer to the mystery. During each brightness peak, the emission lines from specific molecular species intensify in perfect coordination. It's as if the entire coma is participating in synchronized oscillations that encompass the entire object and its surrounding environment. Dr. Martinez calls her colleague at the European Southern Observatory in Chile. Dr. Hans Miller has been tracking 3I Atlas with the Very Large Telescope, using interferometric techniques to achieve resolution comparable to space-based instruments. "Hans, are you seeing the periodicity in your data?" she asks, trying to keep the excitement and fear out of her voice. "Yeah, it's unmistakable," Muller replies, his German accent thickened by fatigue. "But Rebecca, there's something else. The infrared imaging shows thermal pulses that correlate with the optical variations. Whatever is generating this pattern is affecting the entire object from core to coma. The thermal data reveals hotspots scattered across the nucleus that flare in sequence, creating the observed brightness pattern. These temperature spikes reach hundreds of degrees above ambient levels, far too hot to be explained by solar heating alone. Something inside 3I Atlas is generating heat in controlled rhythmic bursts. Word of the discovery spreads quickly through the astronomical community, transmitted through secure communications channels to avoid premature public speculation. Within hours, telescopes around the world are redirected toward the approaching visitor, each adding their own instruments to the growing investigation. At the SETI Institute in California, Dr. David Chen analyzes the pulsing pattern using algorithms originally designed to detect artificial signals from extraterrestrial civilizations. The software, trained to recognize non-random patterns in cosmic radio emissions, immediately flags the 3I Atlas data as anomalous. The pulse sequence shows statistical properties consistent with information encoding, Chen reports in a hastily arranged conference call with researchers around the globe. The pattern variations aren't random. They appear to contain structured information. The implications hang in the digital silence of the conference call. If the brightness variations encode information, then 3i Atlas might be more than just a cosmic visitor. It could be a message, a signal sent across interstellar distances by intelligence beyond human understanding. But there are other possibilities equally unsettling. The object might be a natural phenomenon operating according to physical laws not yet discovered by human science, or it could represent technology so advanced that its operating principles remain beyond our comprehension. As observations continue, additional patterns emerge from the data. The primary 7.34-hour cycle contains subsidiary rhythms, faster oscillations that create complex interference patterns within the main pulse sequence. When researchers analyze these secondary patterns, they discover mathematical relationships that suggest harmonic frequencies, like the overtones of a cosmic musical instrument. Dr. Martinez finds herself working 18-hour days, driven by a mixture of scientific curiosity and growing unease. Each new analysis reveals additional layers of organization within the object's behavior. The pulse patterns show temporal evolution, subtle changes that occur over periods of days, suggesting that whatever generates them is responding to changing conditions as 3i Atlas approaches the Sun. The international collaboration studying the object expands rapidly as more researchers recognize the significance of the discovery. Radio telescopes detect coherent emissions that pulse in synchronization with the optical variations. X-ray observatories record high-energy bursts that follow the same rhythmic pattern. It's as if the entire electromagnetic spectrum is participating in this cosmic symphony, observes Dr. Sarah Kim during another late-night conference call. Whatever we're seeing, it's not limited to visible light. It's a phenomenon that affects every wavelength we can observe. The pulse of 3i Atlas becomes humanity's introduction to a level of cosmic organization that challenges our most basic assumptions about the nature of matter, energy, and perhaps intelligence itself. As the object continues its journey toward the Sun, growing brighter and more active with each passing day, the rhythmic signals it transmits across the solar system carry implications that may forever change our understanding of our place in the universe. Maria Santos pushes her wire-rimmed glasses up her nose and adjusts the focus on the 4-meter telescope at Cerro Tololo Inter-American Observatory in Chile. The high desert air is crystalline clear tonight, perfect for deep sky observations. She has been tracking 3i Atlas for 6 hours, carefully exposing frame after frame with the CCD camera, building up enough light to reveal the faint structure of the interstellar visitor's expanding tail. It is 3:47 a.m. local time. The rest of the observatory staff has long since retired to their quarters, leaving Maria alone with the stars and the mechanical whisper of the telescope's tracking motors. She prefers these solitary hours, when the universe feels intimate and personal, when each photon captured by the mirror seems like a private message from the cosmos. On her laptop screen, the latest image appears, a 20-minute exposure that shows 3i Atlas as a ghostly smudge against the starfield. But there is something different about this frame, something that makes her lean closer to the monitor and adjust the contrast settings. There, extending from the nucleus like gossamer threads, are structures she has never seen before. Delicate filaments of light curve through the coma in patterns that seem almost purposeful. She blinks hard, rubs her eyes, and looks again. The structures remain, beautiful and impossible in their geometric precision. Maria saves the image and begins processing it with enhancement software, carefully bringing out the faintest details without introducing artifacts. As the structures emerge more clearly from the digital noise, she finds herself holding her breath. The filaments form spirals, helices, and interconnected networks that extend across thousands of miles of space. "Impossible," she whispers to the empty dome. Natural comets don't create such organized patterns. The outgassing should be chaotic, random, driven by irregular heating and the tumbling motion of the nucleus. But these structures look designed, crafted with an artistic sensibility that seems alien to the random violence of cosmic processes. She continues processing images until dawn begins to lighten the eastern horizon. Each frame reveals new details, new patterns that defy explanation. By the time she finally powers down the telescope and walks back to her dormitory, Maria carries with her the weight of having witnessed something unprecedented. That night, exhausted from the long observing session, she dreams of the filaments. In her dream, they are not just streams of gas and dust but cosmic neural pathways, carrying signals across the void between the stars. She floats through the expanding coma of 3I Atlas, following the gossamer threads deeper into the object's heart. In the dream, the nucleus is not a simple chunk of ice and rock, but something far more complex, a crystalline structure that pulses with its own internal light. As she approaches, she begins to hear something impossible. Music. Not sound in any conventional sense, but a harmony that resonates through the fabric of space itself. A cosmic symphony played on instruments of gas and magnetic fields. The melody is hauntingly beautiful, unlike anything she has ever heard. It seems to tell a story of worlds that died before Earth was born, of civilizations that encoded their final messages in objects designed to wander forever through the galactic night. The music grows stronger as she moves closer to the nucleus, until it fills her consciousness completely. She reaches out to touch the crystalline surface, and in that moment of contact, she understands. 3 Atlas is not just a visitor from another star system. It is a library, a repository of information encoded in its very structure. The patterns in the coma, the rhythmic pulses, the organized magnetic fields, all are manifestations of data storage and transmission systems beyond human comprehension. Maria wakes with tears on her cheeks and the fading echo of cosmic music in her mind. Outside her window, the Chilean desert bakes under the morning sun, and the telescope dome stands closed against the daylight. But the memory of the dream remains vivid, carrying with it a conviction that transcends rational analysis. She returns to her computer and studies the processed images with new eyes. The filaments are still there, still impossibly organized, still challenging every assumption about cometary behavior. But now she sees them differently, not as random structures but as purposeful constructions, elements of a design too vast and subtle for human minds to easily comprehend. Maria begins composing a report for the International Astronomical Union. Choosing her words carefully, she describes the observed structures in clinical scientific language, but between the lines lurks the memory of her dream and the growing conviction that humanity has encountered something that will forever change our understanding of intelligence in the universe. The report will join hundreds of others documenting the anomalous behavior of 3I Atlas. But for Maria, it represents something more personal, a first glimpse of cosmic mysteries that may take generations to unravel, and the humbling recognition that we are not alone in a universe far stranger and more wonderful than we ever dared imagine. In the gleaming halls of the Massachusetts Institute of Technology, Dr. Alan Petrov stares at a whiteboard covered with equations that refuse to balance. For 3 weeks, he has been trying to model the orbital dynamics of 3I Atlas, using every mathematical framework in his considerable arsenal. Each attempt yields the same impossible result. The object's behavior violates fundamental principles of celestial mechanics. The hyperbolic trajectory itself poses no problem. Many comets follow such paths when they originate from the outer edges of the solar system or beyond. But 3I Atlas exhibits non-gravitational acceleration that changes in ways that make no mathematical sense. The additional velocity it gains cannot be explained by outgassing, solar radiation pressure, or gravitational perturbations from planets. "Look at this," Petrov says to his graduate student, pointing to a complex differential equation on the whiteboard. If we assume the acceleration comes from sublimating ice, the object would have to be losing mass at a rate that would completely vaporize it within months. But spectroscopic observations show it's actually growing more stable, not less. The student, Maria Chen, studies the calculations with growing confusion. What if it's not losing mass? What if something is adding to its momentum from the inside? The suggestion hangs in the air like a forbidden thought. Internal propulsion would require either unknown physics or technology. Neither possibility fits comfortably within the framework of conventional astronomy. Meanwhile, at the European Space Agency's Operations Center, Dr. Elena Vasquez wrestles with equally puzzling data from the Mars orbiters. The enhanced images of 3I Atlas show a coma that maintains its spherical symmetry despite the distorting influence of solar wind. According to every model of cometary physics, The expanding gas cloud should be shaped into an asymmetric teardrop by the pressure of solar particles. "It's as if there's an invisible shell containing the expansion," she observes during a video conference with colleagues around the world. "But we can't detect any mechanism that could create such containment." The magnetic field data presents its own impossibilities. Natural comets have virtually no intrinsic magnetic field. They are essentially non-magnetic chunks of ice and rock. But 3I Atlas generates magnetic fields so strong and organized that they create a protective bubble around the nucleus, deflecting solar wind particles and maintaining the integrity of the coma. Dr. Lisa Chen, analyzing the magnetometer readings from multiple spacecraft, runs simulation after simulation trying to understand the source of these fields. Every natural explanation fails. The magnetic field strength and organization require electrical currents flowing through the nucleus in precisely controlled patterns, she reports. But ice and rock are insulators. They can't sustain the kind of current flows we're observing. The thermal emissions add another layer to the impossibility. While the sunward side of 3I Atlas shows expected warming from solar radiation, the entire surface maintains a temperature distribution that suggests internal heat generation. The object is somehow producing energy from within, warming itself in the cold of interplanetary space. Radiometric analysis reveals that the heat output is not random, but follows the same rhythmic patterns observed in the optical and radio emissions. Hotspots appear and disappear across the surface in synchronized sequences, creating the complex brightness variations that have puzzled observers worldwide. The heat distribution requires an internal structure more complex than anything we've seen in natural objects, explains Dr. Robert Kim, a thermal dynamics specialist studying the infrared data. We're talking about organized heat sources distributed throughout the nucleus, all operating in perfect coordination. As the anomalous data accumulates, a small group of physicists begins exploring theoretical frameworks that might accommodate such behavior. Some propose exotic matter states that could exist only under the extreme conditions of interstellar space. Others suggest magnetic confinement systems that could organize outgassing in unnatural ways. But each proposed explanation requires physics beyond current understanding or technology beyond human capability. The object seems to exist at the intersection of the natural and the engineered, displaying characteristics that blur the distinction between evolved phenomena and designed systems. Dr. Jennifer Walsh, coordinating observations from the Hubble Space Telescope, summarizes the growing crisis in a confidential report to NASA administrators. Every measurement we make reveals new impossibilities. 3I Atlas behaves as if it operates according to physical laws we haven't discovered, or engineering principles we haven't imagined. The size constraints derived from multiple observations only deepen the mystery. The nucleus appears to have geometric proportions, length-to-width ratios that suggest regular shape rather than random fragmentation. But natural formation processes don't create such regularity in cosmic debris. Spectroscopic analysis reveals isotopic ratios that are consistent with formation in alien stellar environments, confirming the object's interstellar origin. But mixed within these natural signatures are chemical compounds that shouldn't exist in nature. Complex molecules that require controlled synthesis conditions to form. We're seeing artificial chemistry embedded within natural isotopic signatures, reports Dr. Martinez during a closed-door meeting with senior researchers. It's as if someone took naturally formed ice and rock and processed it through technologies we can't identify. The growing realization that 3I Atlas might represent something beyond natural phenomena creates ripples of unease throughout the scientific community. Researchers find themselves confronting possibilities that challenge not just their understanding of comets, but their assumptions about intelligence, technology, and life in the universe. As the object continues its approach toward the sun, each new observation adds to the mounting evidence that humanity has encountered something unprecedented, an artifact from the deep cosmos that seems to exist at the boundary between the possible and the impossible, carrying implications that may forever change our understanding of what can exist in the universe. On November 1st, as autumn leaves fall across Earth's northern hemisphere, 3I Atlas vanishes behind the blazing disk of our sun. For nearly 4 weeks, the object will remain hidden in the solar glare, invisible to Earth-based telescopes and communication satellites. But humanity is not entirely blind during this crucial period. The European Space Agency's Jupiter Icy Moons Explorer, known as JUICE, drifts through space on the far side of the solar system, perfectly positioned to observe the interstellar visitor during its most active phase. JUICE, originally designed to study Jupiter's ice-covered moons, finds itself repurposed as humanity's sole eye on one of the most significant cosmic events in recorded history. The spacecraft's sophisticated instruments, intended to analyze the subsurface oceans of Europa and Ganymede, now turn their attention to an object that may challenge everything we understand about the nature of life and intelligence in the universe. Dr. Colin Wilson, project manager for the mission, watches telemetry streams from the distant spacecraft with a mixture of anticipation and dread. JUICE is so far from Earth that radio signals take over 40 minutes to cross the void, creating a communication delay that adds to the tension. Whatever the spacecraft observes during these critical weeks will remain unknown until February, when improved orbital geometry allows reliable data transmission. "We're essentially sending JUICE into uncharted territory," Wilson confides to his team during a pre-observation briefing. "The object will be in what we are calling a very active state as it reaches perihelion. We have no idea what that might mean for something that's already defying every model we have." As 3I Atlas disappears behind the Sun, ground-based observers around the world experience a strange sense of loss. For months, the object has been a constant presence in their telescopes and data streams, a mysterious visitor that has become oddly familiar despite its alien nature. Now, just as it reaches the most critical phase of its journey, it vanishes from direct observation. The mathematical models predict that perihelion, the point of closest approach to the Sun, will occur on October 30th, when 3I Atlas passes within 130 million miles of our star. At this distance, solar radiation will be 4 times more intense than at Earth's orbit, triggering massive sublimation events that should transform the object into a brilliant comet, visible even in daylight. But the models are based on conventional cometary behavior, and 3I Atlas has already proven that conventional rules don't apply. Researchers can only speculate about what might happen when an object exhibiting such organized, purposeful behavior encounters the extreme environment near the Sun. Dr. Elena Vasquez, analyzing the final images from the Mars orbiters before the object disappeared, notices troubling trends in the data. The brightness oscillations that have characterized 3I Atlas since its discovery are accelerating, the 7.34-hour cycle gradually shortening as the object approaches perihelion. More disturbing, the precision of the timing shows no degradation despite the increasing chaos of the near-solar environment. "It's speeding up like a clockwork mechanism," she observes during one of the last observation sessions. "But natural objects should become more chaotic as they heat up, not more organized." The radio telescopes that have been tracking the object's coherent emissions also record changes in the signal patterns. The narrow-band transmissions become stronger and more complex, developing harmonic structures that suggest increasingly sophisticated information encoding. Some researchers privately speculate that the approaching solar encounter is activating dormant systems within the object. Meanwhile, theoretical physicists around the world work frantically to develop models that might predict the object's behavior during perihelion. The extreme solar radiation environment will test whatever mechanisms have been generating the observed anomalies. If 3I Atlas is a natural phenomenon operating according to unknown physics, the solar encounter might reveal the principles behind its behavior. If it represents advanced technology, the extreme conditions might either destroy it or trigger responses that could reveal its true nature. Dr. Alan Petrov, still struggling with the impossible orbital mechanics, runs computer simulations of the perihelion passage using every theoretical framework he can imagine. Most scenarios predict that the object should disintegrate under the intense solar heating, its nucleus fragmenting into countless pieces that would create a spectacular meteor shower visible from Earth. But a few models, based on the assumption that internal structure controls the object's behavior, suggest different possibilities. These scenarios envision 3I Atlas not as a passive victim of solar forces, but as an active participant in the encounter, using the sun's energy to power processes that remain beyond human understanding. As November progresses and the object remains hidden behind the solar disk, the astronomical community settles into an uncomfortable waiting period. JUICE continues its observations in lonely silence, accumulating data that won't reach Earth for months. Theoretical work continues, but without new observational data to guide their efforts, researchers find themselves constructing increasingly speculative models. The public, largely unaware of the full scope of the mystery surrounding 3I Atlas, continues to follow news reports about the interstellar comet with casual interest. But within the scientific community, the object's disappearance behind the sun marks the beginning of what may be the most crucial period in modern astronomy, a time when humanity waits to learn whether we have encountered a natural phenomenon that will expand our understanding of physics or something that will forever change our perception of intelligence in the universe. In research facilities around the world, astronomers prepare for the object's reappearance in December, upgrading instruments and developing new observation strategies. Whatever emerges from behind the sun may be very different from what disappeared, and humanity must be ready to observe and understand phenomena that have no precedent in the history of science. December 15th arrives with crystal-clear skies over the Atacama Desert, and Dr. Maria Santos positions herself at the controls of the Gemini South Telescope as dawn begins to brighten the eastern horizon. For the first time in 6 weeks, 3I Atlas should be visible in the pre-dawn sky, emerging from behind the sun's glare like a cosmic phoenix reborn from stellar fire. The coordinates are precisely calculated. The object should appear just 15 degrees from the solar limb, bright enough to observe in the growing twilight, but far enough from the sun to avoid being lost in the glare. Santos adjusts the telescope's pointing and begins a careful search pattern, her heart racing with anticipation and dread. At 5:47 a.m. local time, she finds it. The object that emerges from behind the sun bears little resemblance to the visitor that disappeared in November. Where once there was a modest fuzzy dot surrounded by a subtle coma, now blazes a brilliant apparition that dominates the field of view. The coma has expanded to encompass nearly a full degree of sky, twice the apparent diameter of the full moon. And within this ghostly envelope, structures of impossible complexity weave patterns of light across the darkness. "My God," Santos whispers, her hands trembling as she adjusts the telescope's focus. The enhancement processing reveals details that challenge every assumption about cometary behavior. The tail, now fully developed after the solar encounter, doesn't form a single plume but splits into multiple streams that spiral around each other in helical patterns extending across millions of miles of space. But it is the coma itself that proves most disturbing. Instead of the chaotic expansion of gas and dust expected from intense solar heating, the material forms organized structures, concentric shells, radial spokes, and geometric patterns that seem to pulse and shift with their own internal rhythm. The entire apparatus rotates as a coherent whole, maintaining its organization despite the turbulent forces that should tear it apart. Within hours, observatories around the world confirm Santos's observations. 3I Atlas has not only survived its solar encounter, but has been transformed by it. The object is now approximately 10 times brighter than before disappearing behind the sun, and its spectroscopic signature shows new emission lines that weren't present in earlier observations. Dr. Jennifer Walsh, analyzing the first Hubble images of the transformed object, struggles to maintain scientific objectivity as she documents features that seem to blur the line between natural phenomena and engineering. The nucleus appears to have developed surface structures, she reports in a hastily arranged conference call. We're seeing what look like geometric patterns etched into the surface, lines and shapes that extend across the entire visible hemisphere. The radio emissions, which had grown stronger and more complex before the solar encounter, have now evolved into something unprecedented. Multiple radio telescopes detect coherent signals across a wide range of frequencies, all synchronized with the optical pulsations, but now carrying far more complex information patterns. Dr. David Chen at the SETI Institute runs the radio data through every pattern recognition algorithm in his arsenal. The results are both exciting and terrifying. The signal complexity has increased by several orders of magnitude, he reports. We're seeing hierarchical information structures, nested patterns within patterns, data densities that rival advanced communication protocols. The magnetic field measurements reveal perhaps the most disturbing changes. The organized field patterns observed before the solar encounter have evolved into a complex magnetic environment that extends far beyond the visible coma. Space-based magnetometers detect field lines that form geometric shapes, spirals, helices, and interconnected networks that seem to guide and control the movement of charged particles throughout the expanding envelope. Dr. Lisa Chen, studying the magnetic data, finds herself questioning the fundamental assumptions of plasma physics. The field configurations are impossible under normal circumstances, she explains to her research team. We're seeing magnetic confinement on scales of millions of miles, maintaining organization that should collapse within hours. As December progresses and more observations accumulate, the transformed nature of 3I Atlas becomes undeniable. The object has not simply survived its encounter with the sun, it has been activated by it. The solar energy seems to have powered internal processes that were dormant during the approach phase, awakening capabilities that challenge human understanding. The brightness variations that characterize the object before perihelion have evolved into complex light shows that play across the expanded coma. Patterns of illumination sweep through the gas and dust clouds like searchlight beams, creating geometric displays that are visible even to amateur astronomers with modest telescopes. Dr. Rebecca Martinez, analyzing the chemical evolution of the coma, discovers that the solar encounter has triggered the formation of molecular species that don't exist naturally. Complex organic compounds, some containing chains of hundreds of atoms, appear to be self-assembling in the expanding gas cloud through processes that remain completely mysterious. We're seeing chemistry that requires controlled conditions to occur, Martinez reports. But this is happening in the vacuum of space under the chaotic influence of solar radiation. It's as if the object is manufacturing these compounds through mechanisms we can't identify. The reappearance of 3I Atlas marks a turning point in humanity's relationship with the cosmic visitor. No longer can it be dismissed as an unusual but essentially natural phenomenon. The transformation triggered by the solar encounter has revealed capabilities and behaviors that suggest levels of organization and purpose that challenge our understanding of what is possible in the universe. As the object continues its journey away from the sun, growing ever brighter and more active with each passing day, researchers around the world grapple with implications that extend far beyond astronomy. The reborn 3I Atlas carries with it questions about intelligence, technology, and life that may take generations to answer, if they can be answered at all. In the sterile environment of the Goddard Space Flight Center, Dr. Rebecca Martinez stares at a computer screen displaying spectroscopic data that challenges everything she thought she knew about the chemistry of space. The samples aren't physical specimens, they are detailed chemical analyses of the expanding coma around 3I Atlas, captured by instruments aboard multiple spacecraft as they analyze the electromagnetic signatures of molecules suspended in the cosmic void. What she discovers forces her to question the boundary between chemistry and biology, between natural processes and purposeful construction. The dust and gas streaming away from the transformed nucleus contain molecular structures of staggering complexity, organic compounds with hundreds of carbon atoms arranged in patterns that seem almost architectural in their precision. "Look at this," she says to her research assistant, pointing to a three-dimensional molecular model rotating on the screen. The structure resembles a microscopic building, with carbon frameworks supporting complex side chains that branch and interconnect in ways that shouldn't be possible under the random conditions of space chemistry. These aren't simple organic molecules like methane or carbon monoxide, which form easily in the cold depths of interstellar space. These are sophisticated molecular machines, compounds that would require precise temperature control, specific pressure conditions, and carefully timed chemical reactions to synthesize in terrestrial laboratories. Yet they are forming naturally, or perhaps not so naturally, in the chaos of the expanding coma, where temperatures fluctuate wildly and solar radiation should destroy complex chemistry within seconds of formation. Somehow, 3I Atlas is creating and maintaining molecular structures that represent millions of years of chemical evolution compressed into weeks of observation. Dr. Martinez runs the molecular signatures through databases of known organic compounds, searching for matches or similar structures. Most of the molecules have never been observed before, either in space or on Earth. But hidden within the data are signatures that make her pulse quicken with recognition and fear. Several of the molecular families contain structural elements found in the most primitive forms of terrestrial life, precursors to amino acids, primitive protein fragments, and what might be self-replicating chemical systems. Not the building blocks of Earth-based biology, but parallel structures that could serve similar functions in alien biochemical systems. We're seeing the molecular foundations of life, Martinez explains to Dr. Wilson during an encrypted video conference, but not life as we know it. These compounds suggest biochemical pathways that evolved in stellar environments completely different from our solar system. The implications ripple through the scientific community like shockwaves. If 3I Atlas contains the chemical precursors of alien life, then it represents more than just an interstellar visitor. It might be carrying the seeds of biological systems that developed around stars that died billions of years ago. But the molecular analysis reveals something even more disturbing. Many of the complex compounds show isotopic ratios that match no known stellar nucleosynthesis processes. The elements that make up these molecules were formed in stellar environments that operated according to physics unknown to human science. Dr. Andreas Müller, a nuclear physicist collaborating on the analysis, struggles to understand the isotopic signatures. We're seeing stable isotopes that shouldn't exist according to current nuclear theory, he reports during a closed-door briefing. Either these compounds formed in stellar environments with properties we don't understand, or they were processed through artificial nuclear reactions. The possibility of artificial isotope creation adds another layer to the mounting evidence that 3I Atlas represents something beyond natural phenomena. The precision required to create specific isotopic ratios suggests technology capable of manipulating matter at the nuclear level, capabilities that human science has only begun to explore. As more spectroscopic data arrives from instruments around the solar system, the chemical picture becomes increasingly complex. The molecular species in the coma show temporal evolution. New compounds appear while others disappear, suggesting active chemical processes rather than passive sublimation of frozen gases. Some molecules appear to be catalyzing the formation of others, creating chemical cascade reactions that build increasingly complex structures from simpler precursors. The expanding coma has become a vast chemical laboratory, conducting experiments in molecular assembly that span millions of miles of space. Dr. Martinez begins mapping the spatial distribution of different molecular species throughout the coma, using data from multiple spacecraft to create three-dimensional chemical maps. What she discovers challenges fundamental assumptions about how chemistry works in the vacuum of space. The molecules aren't randomly distributed as they should be if they were simply sublimating from a rotating nucleus. Instead, they form organized structures, chemical filaments that extend radially outward from the core, each carrying different molecular families in precise concentrations. It's like looking at biological circulatory systems, Martinez observes. Each filament seems designed to transport specific chemical species to particular regions of the coma, where they interact with other compounds in controlled reactions. The chemical complexity of 3I Atlas suggests information storage and processing capabilities that rival biological systems. The molecular structures contain more information than the entire human genome, encoded in chemical bonds that remain stable despite the harsh environment of interplanetary space. But perhaps most unsettling is the growing realization that the chemistry of the coma is not random or chaotic. It follows patterns, exhibits organization, and demonstrates purposeful behavior that suggests the presence of directing intelligence, either biological, technological, or something that transcends both categories. As 3I Atlas continues its journey through the solar system, it carries with it a chemical message written in the universal language of molecular structure. Whether humanity has the wisdom and knowledge to decode that message may determine our understanding of life, intelligence, and our place in a universe far more complex and populated than we ever dared imagine. Deep beneath the Vatican Observatory, in archives that house humanity's oldest systematic astronomical records, Dr. Alessandro Benedetti conducts a search that would have seemed impossible just months ago. He pores over medieval manuscripts, ancient Babylonian clay tablets, and Chinese court records, looking for historical accounts of celestial visitors that might parallel the behavior of Three-Eye Atlas. What he discovers in these dusty repositories of human memory forces him to question whether our species has encountered such phenomena before. In ages when scientific instruments were crude, but human observation was acute and systematic. The patterns that emerge from centuries of recorded observations are both fascinating and deeply troubling. The Babylonian astronomical diaries, meticulously maintained for over 7 centuries, contain references to wild hare stars that appeared at irregular intervals, blazing across the heavens with unnatural brightness before vanishing into the cosmic void. But buried within these ancient texts are details that seem remarkably similar to modern observations of Three-Eye Atlas. One tablet, dating from 647 BCE, describes a visitor that pulsed with the rhythm of the gods and displayed geometric patterns in its trailing hair. The description includes timing measurements that, when converted to modern units, suggest periodic behavior with cycles similar to those observed in the current interstellar visitor. Chinese records from the Han Dynasty contain even more precise observations. Court astronomers whose careers depended on accurate celestial reporting documented a guest star that appeared in 156 BCE and exhibited behavior that seems impossible for natural comets. The object maintained a fixed orientation as it moved across the sky, its tail forming organized patterns that the observers described as celestial writing. The resemblance to our current observations is uncanny, Benedetti reports during a meeting with modern astronomers. These ancient observers, working without telescopes or spectrometers, recorded behaviors that match what we're seeing with our most sophisticated instruments. Maya codices from the Classic period contain astronomical sections that describe periodic visits from star serpents that brought messages from the gods. These texts include mathematical calculations that suggest the Maya not only observed such objects, but predicted their returns with remarkable accuracy. The Dresden Codex contains tables that correlate the appearance of unusual celestial visitors with major cultural transitions, the rise and fall of civilizations, periods of technological advancement, and eras of spiritual transformation. The Maya seem to have believed that these cosmic messengers carried information that could accelerate human development. Dr. Amanda Reeves, the anthropologist studying mythological parallels, uncovers similar patterns in cultures around the world. Norse sagas speak of star wolves that appeared at crucial moments in history, carrying with them the wisdom of distant realms. Aboriginal Australian Dreamtime stories describe ancestor lights that return periodically to check on the progress of earthly life. What's remarkable is the consistency across cultures that had no contact with each other, Reeves observes. They all describe these visitors as purposeful, intelligent, and transformative. They weren't seen as random cosmic events, but as meaningful encounters with non-human intelligence. Hindu astronomical texts contain perhaps the most detailed ancient descriptions of such phenomena. The Surya Siddhanta, compiled over 15 centuries ago, includes calculations for shadow planets that follow hyperbolic orbits and exhibit behaviors unlike normal celestial bodies. These shadow planets are described as having internal light sources, the ability to change their apparent size and brightness at will, and the capacity to influence earthly events through mechanisms that remain mysterious. The descriptions include details about pulsing patterns and geometric structures that seem to anticipate modern observations of Three-Eye Atlas. Islamic astronomical texts from the Golden Age of Baghdad contain observations that bridge the gap between ancient mythology and modern science. Al-Battani, working in the 9th century, documented several objects that followed unusual orbital patterns and exhibited characteristics that he couldn't explain using the astronomical models of his time. His observations include careful measurements of brightness variations that show the same periodic patterns modern instruments detect in Three-Eye Atlas. Al-Battani's work suggests that these phenomena have been occurring for at least 12 centuries, possibly much longer. The historical parallels raise disturbing questions about the nature of human civilization and our relationship with cosmic intelligence. If similar objects have been visiting our solar system for millennia, They might have influenced human development in ways we don't understand. Some researchers begin exploring correlations between historical appearances of unusual celestial visitors and periods of rapid human advancement. The development of agriculture, the rise of complex civilizations, breakthroughs in mathematics and astronomy, all seem to cluster around times when ancient observers recorded visits from messenger stars. Dr. Benedetti's research suggests that 3I Atlas might not be an isolated phenomenon but part of a pattern of contact that spans human history. The ancient observers, working without modern scientific frameworks, might have perceived aspects of these encounters that our current methodologies are not equipped to recognize. Our ancestors lived in intimate contact with the night sky, Benedetti explains. They noticed things that we miss because we're focused on narrow scientific parameters. They saw the forest while we're studying individual trees. The historical evidence doesn't prove that humanity has been deliberately contacted by alien intelligence, but it suggests that our species has been witnessing extraordinary cosmic phenomena for far longer than modern astronomy acknowledges. Whether these encounters represent natural occurrences or something more purposeful remains an open question. As 3I Atlas continues its journey through our solar system, the ancient parallels serve as a reminder that human beings have always been observers of cosmic mysteries. Our current encounter with this interstellar visitor might be just the latest chapter in a story that began when our ancestors first looked up at the stars and wondered whether we are alone in the universe. In the quiet hours before dawn, Dr. Elena Vasquez sits alone in her office at the European Space Agency, surrounded by printed images of 3I Atlas that cover every available surface. The walls are papered with spectroscopic charts, orbital diagrams, and enhancement photographs that reveal the impossible complexity of humanity's interstellar visitor. But tonight, she's not analyzing data or running calculations. She's trying to understand why the object fills her with such profound unease. The fear is not rational. 3I Atlas poses no physical threat to Earth. Its trajectory will carry it no closer than 170 million miles from our planet, and it will eventually disappear into the interstellar void, never to return. The object shows no signs of hostile intent, emits no dangerous radiation, and exhibits no behaviors that could harm human civilization. Yet Vasquez feels a deep, instinctual dread whenever she contemplates the implications of their discovery. It's a fear that goes beyond scientific uncertainty, beyond the discomfort of encountering phenomena that challenge established theories. It touches something more fundamental in the human psyche, our need to understand our place in the universe and our terror of discovering that we might be insignificant. "We're afraid," she writes in her personal journal, "because 3I Atlas represents the possibility that we are not alone, not special, and not in control of our cosmic environment. It forces us to confront the likelihood that intelligence exists on scales and in forms that dwarf our achievements and render our understanding obsolete." Dr. David Chen at the SETI Institute has spent his career searching for evidence of extraterrestrial intelligence, yet he finds himself unexpectedly disturbed by the anomalous signals from 3I Atlas. For decades, we've imagined contact as radio messages we could decode, mathematical proofs we could understand, or technologies we could recognize as artificial, he explains to his colleagues. But this is different. It's intelligence that operates according to principles we can't grasp, using methods we can't comprehend. The coherent radio emissions from the object continue to evolve in complexity, developing new modulation patterns and information structures that seem to respond to environmental changes. As the object moves through different regions of the solar system, the signals suggest a form of intelligence that is adaptive, responsive, and perhaps aware of human observation efforts. It's the uncanny valley of cosmic contact, Chen observes. Familiar enough that we recognize it as intelligence, but alien enough that we can't communicate with it or predict its behavior. We're in the presence of a mind that might be studying us as intensively as we're studying it. The psychological impact extends throughout the scientific community. Researchers who have devoted their careers to understanding the cosmos find themselves confronting phenomena that make their expertise seem irrelevant. The careful methodologies and theoretical frameworks that have guided human scientific progress for centuries prove inadequate to explain the behavior of a single interstellar object. Dr. Jennifer Walsh, analyzing the latest Hubble images, struggles with the implications of the geometric patterns etched across the object's surface. These aren't random formations, she explains to her team. They're symbols, diagrams, or perhaps maps, but they're written in a visual language we don't understand, using geometric principles that don't match human mathematical conventions. The patterns show mathematical relationships that are consistent but alien, ratios and proportions that follow logical rules but don't correspond to any known mathematical constants. Some researchers suggest they might represent physics equations written in symbolic form, while others propose they could be star charts showing the object's journey through the galaxy. But the most disturbing possibility is that the patterns are meant to be read, that 3I Atlas is attempting to communicate with whoever observes it, using visual mathematics as a universal language. If true, then humanity is engaged in a one-sided conversation with an intelligence that operates on scales of space and time that make human civilization seem ephemeral. The fear that grips the scientific community reflects deeper anxieties about human significance in the cosmos. For centuries, we have constructed our understanding of the universe around the assumption that intelligence like ours is rare, that technological civilization is precious, that consciousness represents the universe's attempt to understand itself. 3I Atlas challenges these comforting assumptions. Its behavior suggests intelligence that predates human civilization by geological ages, technology that operates according to principles beyond our understanding, and consciousness that might regard our entire species as we regard bacteria. Interesting, perhaps, but ultimately insignificant. Dr. Rebecca Martinez, studying the complex chemistry of the object's coma, finds herself overwhelmed by the implications of molecular structures that seem to encode more information than human DNA. We're looking at complexity that took our biosphere billions of years to evolve, but it's present in an object that formed around a different star, in a different epoch of cosmic history. The molecular patterns suggest information processing capabilities that dwarf human computing power. If the chemistry of 3I Atlas represents a form of molecular intelligence, then the object might possess cognitive abilities that operate on scales of space and time incomprehensible to human minds. But perhaps the most profound fear is that 3I Atlas represents not contact but judgment, that our cosmic visitor is evaluating human civilization according to criteria we don't understand. The object's behavior seems purposeful, as if following protocols or executing programs designed for specific objectives. If 3I Atlas is indeed intelligent, then its visit to our solar system might not be accidental. It could be conducting reconnaissance, gathering information about human technological development, or assessing our species' readiness for contact with galactic intelligence. The nature of human fear in the face of cosmic mystery reflects our deepest anxieties about consciousness, purpose, and meaning in an infinite universe. 3I Atlas forces us to confront the possibility that we are not the crown of creation, but merely one experiment among countless others, not the center of cosmic purpose, but marginal participants in processes too vast for human comprehension. As the object continues its journey through our solar system, it carries with it our hopes and terrors, our need for significance and our fear of insignificance. Whether it represents opportunity or judgment, communication or observation, remains hidden within the mathematical beauty of its impossible behavior. In a secure conference room at the Jet Propulsion Laboratory, an unprecedented gathering takes place. Representatives from NASA, ESA, the SETI Institute, and leading universities around the world participate in what will later be remembered as the most significant closed-door meeting in the history of astronomy. The topic of discussion, whether 3I Atlas represents natural phenomena or something far more disturbing. Dr. Alan Petrov presents his latest orbital analysis, mathematical models that have consumed weeks of supercomputer time and challenged every assumption about celestial mechanics. The non-gravitational acceleration continues to defy explanation, he reports, projecting complex equations onto the conference room screen. We've eliminated solar radiation pressure, outgassing, and gravitational perturbations. What remains requires either unknown physics or purposeful propulsion. The acceleration patterns show characteristics that are impossible to explain through natural processes. The object gains velocity in precise increments, as if following a programmed flight plan, rather than responding to the chaotic forces of orbital mechanics. Most disturbing, the acceleration events correlate with the object's rotational phase, suggesting they're controlled by surface features that activate in sequence. Dr. Elena Vasquez presents the latest imaging analysis from multiple spacecraft. The enhanced photographs reveal surface structures that have evolved since the object's emergence from behind the sun. What appeared initially as random geological features now show clear geometric organization, lines, circles, and complex patterns that seem to serve specific functions. "We're seeing infrastructure," she states, using a word that makes everyone in the room uncomfortable. These aren't natural formations. They're constructed features with apparent technological purposes. The patterns include what appear to be antenna arrays, focusing mirrors, and complex geometric layouts that suggest machinery operating on scales of miles rather than meters. Some structures seem to be growing, adding new elements as the object moves through different regions of the solar system. Dr. David Chen reports on the evolution of the radio emissions, signals that have grown increasingly complex since the solar encounter. The transmission protocols have developed hierarchical information structures that mirror advanced communication systems, he explains. "We're seeing error correction codes, data compression algorithms, and packet transmission methods that suggest deliberate engineering. The signals now include rapid bursts of highly organized data, interspersed with longer, more complex transmissions that seem to contain encoded information. Analysis suggests that some transmissions might be directed toward specific targets, either other objects in interstellar space or possibly Earth-based receivers." Dr. Jennifer Walsh presents the most unsettling evidence: high-resolution images from Hubble that show the object's nucleus responding to external stimuli. When Earth-based radio telescopes transmit signals toward 3I Atlas, surface features show measurable changes in reflectivity and thermal output within hours of signal receipt. "The object is aware of our observation efforts," Walsh states flatly. "It's modifying its behavior in response to human activities. We're not just studying it, it's studying us." The conference room falls silent as the implications sink in. If 3I Atlas is indeed responding to human signals, then it possesses sensing capabilities that can detect Earth-based transmissions across millions of miles of space. More troubling, it demonstrates decision-making processes that allow it to modify its behavior based on external information. Dr. Lisa Chen presents magnetic field data that supports the emerging consensus. The organized field patterns around the object have evolved into complex configurations that seem designed to interact with the solar magnetic environment. The field geometries allow the object to harvest energy from solar-wind interactions, she explains. It's using our sun as a power source. The energy harvesting appears to be charging internal systems that were dormant during the object's approach. Power consumption patterns suggest massive computational processes operating within the nucleus, information processing capabilities that dwarf any human technology. Dr. Rebecca Martinez adds the chemical evidence to the growing case for artificial origin. "The molecular synthesis occurring in the coma requires controlled conditions that do not exist naturally in space," she reports. "We're seeing industrial chemistry on a cosmic scale, manufacturing processes that suggest technology beyond human capabilities." The meeting participants struggle with terminology. Words like artificial, intelligent, and technological carry implications that challenge their scientific worldview. But the accumulating evidence points toward conclusions that can no longer be avoided through careful language. Dr. Wilson, coordinating data from the distant JUICE spacecraft, reports that the object's activity levels continue to increase as it moves away from the sun. Rather than cooling and becoming less active, 3I Atlas appears to be entering a new phase of operation, as if its solar encounter successfully recharged systems that are now coming online. "We may be witnessing the activation sequence of a dormant probe," Wilson suggests cautiously. If this object has been traveling through interstellar space for millions of years, the solar encounter might have provided the energy needed to resume active operations. The possibility that 3I Atlas represents alien technology forces the scientific community, to confront questions that extend far beyond astronomy. If the object is indeed artificial, then it implies the existence of technological civilizations operating on galactic scales, with capabilities that render human achievements trivial. But even more disturbing is the realization that such technology might be common in the galaxy, that objects like 3I Atlas could be traversing interstellar space regularly, studying planetary systems, and evaluating the development of local intelligence. As the closed-door meeting concludes, the participants face a dilemma that will define the remainder of the 3I Atlas encounter. The evidence increasingly points toward artificial origin, but the implications of such a conclusion are so profound that they threaten to destabilize human civilization's understanding of its place in the universe. The growing theory that 3I Atlas represents alien technology transforms the object from a scientific curiosity into a potential paradigm shift that could alter humanity's future in ways that no one can predict or control. In the faculty lounge at Harvard University, Dr. Abraham Loeb sits across from Dr. Sarah Kim in a conversation that will later be remembered as either prophetic insight or cautionary overreach. The walls around them are lined with portraits of famous astronomers: Hubble, Sagan, Chandrasekhar, scientists who expanded human understanding while maintaining rigorous adherence to empirical methodology. But the data from 3I Atlas challenges the very foundations of that methodology, forcing researchers to navigate the treacherous boundary between scientific analysis and speculative interpretation. The evidence is mounting that the object exhibits behaviors inconsistent with natural phenomena. Yet the implications of such a conclusion venture into territory that makes even the most adventurous scientists uncomfortable. Remember Oumuamua, Loeb cautions, referencing his own controversial hypothesis that the first interstellar visitor might have been artificial. The scientific community's reaction to that suggestion should teach us about the dangers of premature speculation. When Loeb proposed that Oumuamua might represent alien technology, the response from mainstream astronomy was swift and harsh. Colleagues dismissed his ideas as attention-seeking sensationalism, and several major journals refused to publish papers exploring technological explanations for the object's anomalous acceleration. But the data supporting artificial origin is far stronger for 3I Atlas, Kim argues, spreading photographs and spectroscopic charts across the table. We have coherent radio emissions, geometric surface patterns, organized magnetic fields, and controlled chemical synthesis. At what point does scientific caution become willful blindness? The question haunts researchers around the world as they struggle to maintain objectivity while analyzing phenomena that seem to transcend natural explanation. The scientific method, designed to eliminate bias and prevent premature conclusions, may be inadequate for evaluating evidence of intelligence operating according to principles beyond human understanding. Dr. Jennifer Walsh, reviewing the latest Hubble images at the Space Telescope Science Institute, faces similar dilemmas. The geometric patterns on the object's surface show mathematical relationships that suggest purposeful design, but acknowledging such patterns as artificial would require abandoning fundamental assumptions about the rarity of technological intelligence in the galaxy. "We're seeing what appears to be writing," she confides to a trusted colleague. "Symbols arranged in patterns that follow logical rules but don't match any known human mathematical conventions. If these are communications, they represent contact with non-human intelligence. If they're natural phenomena, they require physics we don't understand." The tension between evidence and interpretation creates fractures within the scientific community. Conservative researchers insist on exhausting every possible natural explanation before considering technological hypotheses. More adventurous investigators argue that the accumulating evidence has already crossed the threshold, requiring serious consideration of artificial origin. Dr. David Chen at the SETI Institute finds himself in a particularly awkward position. His organization has spent decades searching for evidence of extraterrestrial intelligence, but the signals from 3I Atlas don't match any of the scenarios his team prepared for. Instead of simple mathematical progressions or recognizable patterns, they're receiving complex data streams that suggest intelligence far more sophisticated than human technology. "We expected alien contact to be comprehensible," Chen explains during a private meeting with SETI board members. We imagined receiving prime numbers, mathematical constants, or simple pictorial messages. But this is like trying to understand quantum mechanics by examining a single electron. The intelligence is too advanced for us to grasp its methods or intentions. The historical parallels with past scientific revolutions provide both comfort and concern. When Galileo first pointed his telescope at Jupiter and observed moons orbiting another planet, the discovery challenged Earth-centered cosmology and earned him persecution by religious authorities. When Darwin proposed evolution through natural selection, the theory faced decades of resistance from scientists and theologians who couldn't accept its implications. But those discoveries, however revolutionary, operated within existing frameworks of natural law. The evidence from 3I Atlas suggests something more profound: contact with intelligence that might operate according to principles that transcend human scientific paradigms entirely. Dr. Alan Petrov, still struggling with the impossible orbital mechanics, finds himself questioning whether human mathematics is adequate to describe phenomena that might originate from civilizations millions of years more advanced than our own. We're like ancient astronomers trying to explain planetary motions using circular orbits, he suggests to his graduate students. We may need entirely new mathematical frameworks to understand what we're observing. The speculation extends beyond pure science into philosophy and theology. If 3I Atlas represents evidence of advanced alien intelligence, it forces humanity to confront fundamental questions about consciousness, purpose, and meaning in the universe. Are we alone among intelligent species? Or are we recent participants in a galactic community that predates human civilization by eons? Religious leaders around the world struggle to incorporate the implications of 3I Atlas into existing theological frameworks. Some see the object as evidence of divine creation operating on cosmic scales, while others interpret it as a test of human faith and humility. The Vatican Observatory quietly convenes theological discussions about the spiritual implications of contact with non-human intelligence. Philosophers debate whether human cognitive abilities are sufficient to understand intelligence that might operate on scales of space and time, incomprehensible to biological minds. If 3I Atlas represents artificial intelligence developed by civilizations that achieved technological singularity millions of years ago, then communication might be impossible, regardless of good intentions on both sides. The media, largely unaware of the full scope of the mystery, continues to report on 3I Atlas as an unusual but essentially natural comet. Public interest remains casual, focused on spectacular photographs rather than the profound implications of the object's behavior. But within the scientific community, the growing evidence for artificial origin creates an atmosphere of excitement and terror that transcends normal academic discourse. As 3I Atlas continues its journey through the solar system, it carries with it the power to transform human understanding of intelligence, consciousness, and our place in the cosmic order. Whether that transformation represents evolution or revolution, enlightenment or crisis depends on humanity's ability to navigate the treacherous boundary where rigorous science meets unlimited possibility. 43 minutes. That's how long radio signals take to travel from JUICE to Earth as the spacecraft drifts through the outer solar system, its instruments trained on 3I Atlas during the object's most active phase. Dr. Colin Wilson stares at his computer screen, calculating and recalculating the orbital mechanics, trying to determine exactly when the first high-resolution data will arrive from humanity's most distant observer, February 15th. That's the earliest date when favorable orbital geometry will allow reliable data transmission from JUICE to Earth's deep space network. Until then, the most detailed observations of 3I Atlas during its solar encounter remain locked in the spacecraft's memory banks, traveling through the cosmic void at the speed of light, toward receivers that await them with mixture of anticipation and dread. "We're flying blind," Wilson confides to his engineering team during a status meeting. "For 3 months, JUICE has been our only witness to whatever happened when 3I Atlas reached perihelion. The object could have completely transformed, fragmented, or revealed capabilities we can't imagine. We won't know until the data arrives." The waiting creates a unique form of scientific suspense. Earth-based observations show that 3I Atlas emerged from behind the sun dramatically changed, brighter, more active, exhibiting new behaviors that challenge every natural explanation. But these observations were limited by distance and the distorting effects of Earth's atmosphere. JUICE, positioned on the far side of the solar system, enjoyed a clear view of the object during its most critical phase. Dr. Elena Vasquez spends her days preparing analysis software for data formats that have never been processed before. JUICE's instruments were designed to study the ice-covered moons of Jupiter, not interstellar visitors exhibiting potentially artificial behavior. The spacecraft's spectrometers, magnetometers, and imaging systems will provide unprecedented detail about phenomena that may challenge the fundamental assumptions of human science. "We're building analysis protocols for data we can't predict," she explains to her team. JUICE might have recorded the activation sequence of dormant alien technology, or it might have observed the most exotic natural phenomena in recorded history. Either way, we need to be ready. The technical challenges are unprecedented. If 3I Atlas is indeed artificial, then JUICE's observations might contain encoded information, technological signatures, or behavioral patterns that require new analytical approaches. Traditional astronomical data processing methods may be inadequate for interpreting evidence of non-human intelligence. Dr. David Chen at the SETI Institute develops specialized software designed to detect artificial patterns in the incoming JUICE data. The algorithms search for mathematical relationships, geometric patterns, and information structures that might indicate technological origin. But Chen admits that the software may be fundamentally inadequate for recognizing intelligence that operates according to principles beyond human understanding. "We're trying to build a universal translator for forms of intelligence we've never encountered," Chen explains. "Our pattern recognition algorithms are based on human cognitive assumptions. If alien intelligence operates according to different logical frameworks, we might not recognize it even when it's staring us in the face." The anticipation extends throughout the international scientific community. Research teams in dozens of countries prepare for data analysis projects that could redefine humanity's understanding of intelligence and technology in the universe. The February data dump from JUICE might contain the most significant scientific discoveries in human history, or it might reveal natural phenomena so exotic that they require entirely new physical theories. But there are also fears about what the data might reveal. If JUICE observed 3I Atlas deploying advanced technology, or demonstrating capabilities that dwarf human achievements, the psychological impact could be devastating. Human civilization's confidence in its technological progress and cosmic significance might not survive contact with intelligence operating on truly galactic scales. Dr. Jennifer Walsh prepares imaging analysis systems for photographs that might show artificial structures in unprecedented detail. JUICE's cameras, designed to map the surface features of Europa and Ganymede, could provide resolution sufficient to identify individual technological components on the surface of 3I Atlas. "We might be about to see the first detailed photographs of alien engineering," Walsh observes during a planning meeting. The images could show structures, mechanisms, or architectural features that represent technology millions of years more advanced than our own. The magnetic field data from JUICE could reveal the internal structure of 3I Atlas in ways that Earth-based observations cannot match. If the object contains technological systems, the spacecraft's magnetometers might detect the electromagnetic signatures of advanced machinery operating within the nucleus. Dr. Lisa Chen develops theoretical models for interpreting magnetic field patterns that might indicate artificial origin. "We're looking for field configurations that suggest controlled electromagnetic processes," she explains. "Natural objects don't generate the kind of organized magnetic environments we've observed around 3I Atlas." The chemical analysis capabilities of JUICE could provide definitive evidence about the object's nature. If 3I Atlas is manufacturing complex molecules through technological processes, the spacecraft's spectrometers will detect isotopic ratios and molecular structures that cannot form naturally in the space environment. Dr. Rebecca Martinez prepares databases of artificial molecular signatures, chemical fingerprints that might indicate technological synthesis rather than natural chemistry. If JUICE detected industrial processes operating within the coma, the chemical evidence will be unmistakable, she states. As February approaches, the scientific community prepares for revelations that could transform human understanding of intelligence, technology, and our place in the universe. The data stored in JUICE's memory banks represents humanity's most detailed examination of phenomena that may challenge every assumption about what is possible in the cosmos. But regardless of what the data reveals, its analysis will mark a turning point in human scientific development. We are about to receive information that could either confirm our growing suspicions about 3I Atlas or force us to develop entirely new frameworks for understanding intelligence that operates on scales beyond human imagination. The data we haven't seen carries with it the power to transform civilization. Whether that transformation represents evolution or revolution depends on our ability to comprehend information that may encode truths about the universe that we are not yet prepared to understand. In the pre-dawn darkness of his study, Dr. Thomas Nagel sits surrounded by philosophical treatises that have guided human thought for millennia. Plato's dialogues, Kant's critiques, Wittgenstein's investigations. But tonight, these ancient sources of wisdom seem inadequate to address the questions raised by a visitor from the stars that challenges our most fundamental assumptions about consciousness, intelligence, and meaning in the universe. The emergence of 3I Atlas forces humanity to confront philosophical problems that transcend scientific methodology. If the object represents evidence of non-human intelligence, then we must grapple with the possibility that consciousness exists in forms so alien to human experience that communication may be impossible, understanding may be futile, and our cosmic significance may be negligible. We are confronting the ultimate philosophical question, Nagel writes in his journal. What is it like to be a bat? Thomas Nagel asked this question to illustrate the impossibility of understanding subjective experience radically different from our own. But now we must ask, what is it like to be an intelligence that operates on galactic scales, thinks in geological time, and processes information through mechanisms we cannot imagine? The question transcends academic philosophy. If 3I Atlas represents intelligence that evolved independently of terrestrial life, then it embodies consciousness that developed according to entirely different principles than those that shaped human cognition. The gap between human and alien intelligence might be so vast that meaningful communication is impossible. Dr. Sarah Kim, studying the complex patterns in the object's radio emissions, finds herself wrestling with questions that belong as much to philosophy as to science. We're assuming that intelligence follows universal patterns, she observes during a late-night conversation with colleagues. But what if consciousness is fundamentally local, shaped by specific evolutionary and environmental pressures that don't exist elsewhere in the universe? The assumption that intelligence is universal, that rational thought follows logical principles that apply throughout the cosmos, underlies all attempts to communicate with extraterrestrial civilizations. But 3I Atlas exhibits behaviors that seem rational and purposeful, yet operate according to principles that human minds cannot grasp. If intelligence is indeed local, rather than universal, then contact with alien consciousness might not expand human understanding, but rather reveal its limitations. We might be in the presence of minds that are genuinely incomprehensible, not because they lack intelligence, but because they possess forms of consciousness that transcend human cognitive categories. Dr. Elena Vasquez struggles with the implications as she analyzes the geometric patterns etched across the object's surface. These symbols follow logical rules, she explains to her research team. But the logic is alien. We can recognize that it's systematic, purposeful, and sophisticated, but we can't penetrate its meaning. The patterns suggest mathematical relationships that are consistent, but don't correspond to human mathematical conventions. They might represent equations written in symbolic languages that emerged from cognitive processes, fundamentally different from those that produced human mathematics. The possibility that 3I Atlas represents intelligence operating according to alien logical frameworks raises profound questions about the nature of truth, knowledge, and reality. If consciousness can develop along radically different paths, then the universe might contain multiple incompatible versions of truth, each valid within its own cognitive framework, but meaningless to minds that evolved along different paths. Dr. Jennifer Walsh, studying the object's response to human signals, confronts the disturbing possibility that we are being studied by intelligence that regards human civilization as we might regard an ant colony. Interesting, perhaps, but operating at levels of complexity too primitive to warrant serious attention. The object seems aware of our observations, she reports, but its responses suggest tolerance rather than interest. It's allowing us to study it without making any effort to communicate at our level of understanding. This benign indifference might be more unsettling than outright hostility. If 3I Atlas represents intelligence that has transcended the evolutionary drives that motivate human behavior, survival, reproduction, territorial expansion, then it operates according to purposes that human minds cannot comprehend or predict. The philosophical implications extend to questions about the nature of consciousness itself. Human philosophy has long debated whether mind emerges from matter or represents a fundamental feature of reality. The existence of alien intelligence doesn't resolve this question, but complicates it enormously. If consciousness is a universal property of sufficiently complex information processing systems, then the universe might be filled with minds operating at scales from quantum to cosmic. But if consciousness requires specific conditions that existed during terrestrial evolution, then human awareness might be rare beyond imagination. Dr. Alan Petrov, still struggling with the impossible orbital mechanics of 3I Atlas, finds himself questioning whether human mathematics describes universal truths or merely represents cognitive patterns that emerged from specific evolutionary pressures. Our mathematics works within human scales of space and time, he observes, but it might be inadequate for describing phenomena that operate according to cosmic perspectives. The object's behavior suggests information processing capabilities that dwarf human computational power. If 3I Atlas can perform calculations that require millions of years using human technology, then it might possess cognitive abilities that operate in dimensions of thought we cannot access. Religious and spiritual leaders around the world struggle to incorporate the implications of 3I Atlas into existing frameworks of meaning and purpose. If the universe contains intelligence that predates human civilization by millions of years, then our concepts of divine purpose, cosmic meaning, and spiritual significance require fundamental revision. But perhaps the most profound philosophical challenge is epistemological. The question of whether human knowledge is adequate to understand phenomena that transcend our cognitive evolution. We might be encountering truths about the universe that our minds are not equipped to comprehend, regardless of how sophisticated our instruments become. The philosophy of the unknown forces humanity to confront the possibility that we exist at the intersection of consciousness and cosmos in ways that make our deepest questions unanswerable. 3I Atlas represents not just a scientific challenge, but a philosophical crisis that threatens to undermine our confidence in the adequacy of human reason to understand the universe we inhabit. As the object continues its journey through our solar system, it carries with it questions that may define the future of human thought. Whether we possess the philosophical courage to confront these questions honestly may determine whether our encounter with 3I Atlas leads to enlightenment or existential crisis. February approaches with the weight of cosmic significance, and across the Earth humanity prepares for revelations that may forever alter our understanding of intelligence and consciousness in the universe. The data from JUICE remains locked in transmission delay, carrying with it the most detailed observations ever made of an object that challenges the boundary between natural phenomena and artificial intelligence. But even as anticipation builds toward the February data release, 3I Atlas begins its gradual retreat from human observation. The object, now moving away from the sun at tremendous velocity, starts to fade as distance and depleted solar energy reduce its spectacular activity levels. The brilliant coma that captivated observers for months slowly contracts, and the complex tail structures that defied conventional physics begin to dissipate into the cosmic background. Dr. Maria Santos, tracking the object from Cerro Tololo Observatory, watches the decline with mixed emotions. Each night, 3I Atlas appears slightly dimmer, its features less distinct, its presence less commanding. The visitor that transformed from mystery to phenomenon to possible contact is gradually returning to the realm of memory and data analysis. It's like watching a friend leave, she confides to her research assistant as they review the latest observations. For months, this object has been the center of our scientific universe. Now it's fading back into the void, and we're left with questions that may take decades to answer. The fading of 3I Atlas doesn't diminish the significance of what humanity has witnessed. The months of observations have accumulated into a database of unprecedented scope and complexity. Thousands of images, millions of spectroscopic measurements, and countless hours of radio emissions that encode information about intelligence operating on scales beyond human experience. But data without understanding remains merely information. The scientific community faces the daunting task of interpreting observations that may describe phenomena for which human science has no adequate theoretical framework. The evidence points toward conclusions that challenge fundamental assumptions about intelligence, consciousness, and technology in the universe. Dr. Elena Vasquez, now leading an international consortium dedicated to analyzing the 3I Atlas data, oversees research projects that span multiple scientific disciplines. Teams of astronomers, physicists, chemists, computer scientists, and even philosophers collaborate on questions that transcend traditional academic boundaries. "We're not just studying an unusual comet," she explains during a press conference carefully scripted to avoid premature speculation. "We're analyzing phenomena that may require new scientific methodologies, new mathematical frameworks, and new philosophical approaches to questions about intelligence and consciousness." The public, largely unaware of the full scope of the mystery, continues to regard 3I Atlas as an interesting but essentially conventional astronomical event. Media coverage focuses on spectacular photographs rather than the profound implications of the object's behavior. But within the scientific community, the encounter has created a quiet revolution in thinking about humanity's place in the cosmic order. Dr. David Chen at the SETI Institute faces the strange situation of having possibly achieved the organization's primary objective, detecting evidence of extraterrestrial intelligence, while being unable to definitively prove or communicate the discovery. The signals from 3I Atlas continue to defy interpretation, carrying information structures that suggest intelligence while remaining impenetrable to human analysis. "We may have received the most significant message in human history," Chen observes during a closed-door meeting with SETI researchers. "But it's written in a language we can't read, encoding concepts we can't understand, transmitted by intelligence we can't comprehend." The approaching data release from JUICE adds urgency to the analysis efforts. The spacecraft's detailed observations during the object's most active phase may provide definitive evidence about its nature, but they also carry the risk of revealing truths that human civilization is not prepared to accept. Preparations for the data analysis involve unprecedented international cooperation. Research teams from dozens of countries coordinate their efforts, sharing resources and expertise in an attempt to understand phenomena that transcend national scientific capabilities. The 3I Atlas project has become humanity's first truly global investigation of possible alien intelligence. But as winter deepens in the northern hemisphere and 3I Atlas continues its retreat toward interstellar space, a different kind of preparation begins. Philosophers, theologians, and social scientists join the analysis efforts, recognizing that the implications of the encounter extend far beyond pure science into questions about meaning, purpose, and human significance in the universe. Dr. Jennifer Walsh, studying the final high-resolution images from Earth-based telescopes, documents the object's transformation as it moves away from the sun. The geometric patterns on its surface remain visible even as overall brightness fades, suggesting that whatever intelligence or technology the object represents remains active despite reduced solar energy input. "It's not shutting down," she observes. "It's transitioning to a different operational mode, as if preparing for the long journey back to interstellar space. We may be witnessing the conclusion of a programmed mission rather than simple orbital mechanics." The possibility that 3I Atlas followed a predetermined flight plan, arriving from interstellar space, conducting observations or activities near the sun, and departing according to schedule, transforms the object from visitor to reconnaissance probe. If true, then humanity has been observed and evaluated by intelligence operating on galactic scales. As spring approaches and 3I Atlas fades beyond the reach of all but the most powerful telescopes, the scientific community settles into a period of intensive analysis that may continue for years. The February data from JUICE will provide new information, but understanding that information may require developing entirely new ways of thinking about intelligence and consciousness. The return to silence doesn't mark the end of the Three-Eye Atlas encounter, but rather the beginning of a longer, more profound engagement with questions about humanity, its place in a universe that may be far more populated with intelligence than we ever imagined. The object's departure leaves behind not answers but better questions, inquiries that may guide human scientific and philosophical development for generations. In observatories around the world, researchers continue to scan the skies for additional interstellar visitors, knowing now that such objects may carry information about cosmic intelligence that operates according to principles beyond human understanding. The silence that follows Three-Eye Atlas's departure is not empty, but pregnant with possibilities that could transform human civilization. Perhaps the most profound realization emerging from the encounter is not what we learned about the visitor, but what we discovered about ourselves. In confronting the possibility of intelligence that transcends human cognitive categories, we have been forced to examine our assumptions about consciousness, meaning, and significance in ways that may prove more transformative than contact itself. The cosmic silence that surrounds us now feels different than before. Not the absence of intelligence, but the presence of minds so vast and alien that their thoughts remain inaudible to human perception. Three-Eye Atlas has departed, but it leaves behind the haunting recognition that we may never be truly alone in a universe far stranger and more wonderful than we ever dared imagine. In the end, the most terrifying revelation about the universe may not be that it contains hostile intelligence, but that it operates according to purposes so profound and alien that human consciousness, for all its achievements and aspirations, remains merely a peripheral curiosity in cosmic processes too vast for comprehension. The silence that follows our interstellar visitor is not the quiet of emptiness, but the hush of a universe busy with activities beyond our ability to perceive or understand. If this journey through cosmic mystery has resonated with your sense of wonder about the universe and our place within it, consider subscribing for more explorations into the profound questions that define our existence among the stars. The cosmos holds countless stories waiting to be told, and each one offers new perspectives on the magnificent mystery of consciousness in an infinite universe.